So as you know, in COVID, what happened? Everybody was in quarantine. No work, no criminal on the road. So police was beating everybody. Even our superhero don't have any work. So because of that, they become healthy because of no work. Now we can see Batman had become healthy and he's trying to lose the weight by skipping on the bridge. But due to his overweight, now this particular bridge is trying to deflect. So we will try to calculate the deflection equation using Galerkin method. Now what is Galerkin method? It is a weighted residual method in which the domain integral of the product of the trial, this is our trial function and this is our residual function. So the product of trial and residual function is equal to 0 up to the limit 0 to d. My weight is increased in COVID, Batman is telling to us. Okay, now if you see fundamental Bernoulli's equation, this is the fundamental equation which you can check in web, or if you have ever heard this Bernoulli's equation, it is EI dw by dx4, means 4 time derivative of the deflection of the beam. Got it? Here W is deflection of the beam, means if you are putting some weight here, so what will be the deflection? So that equation is W. Q is the distributed load for force per unit length. We are assuming here load is uniformly distributed throughout the length. E is the Young's modulus of elasticity. I is the moment of inertia, and EI is collectively known as flexible of rigidity. Again this Hulk came. He will break the bridge. He is trying to break the bridge, but we are going to save the bridge. Now if you see this Euler equation which we have seen in the previous video, if we first differentiate this Euler equation, the first derivative is shear force. What is shear force? Shear force is a force which acts parallel to the direction of the motion of the movement. Normal force is perpendicular to the motion, but it is parallel. Got it? You can consider an example of a scissor. When you are trying to cut which type of force, even it is asked several in competitive exam, what type of force is shear force? Shear force is just like you are taking a scissor and you are trying to cut it, so it will tear out from the middle. Got it? That is shear force. The first derivative of Euler-Bernoulli's equation is shear force. Then second derivative is moment, which we will be using. Got it? So first derivative is shear force, second derivative is moment. Now what is flexible rigidity? Flexible rigidity is the product of Young's modulus and moment of inertia. It is a resistance which is offered by the structure. See, it's just like an inherent property. If somebody is trying to come to beat you, definitely you will put a resistance. Okay, we will see. Got it? It's like that. It's an inner resistance which offered by anything, whether it's a human being or non-living things. Got it? It won't, if you suppose I am applying a force on steel, it won't deform because it has inner resistance. So W is the deflection, and first derivative of deflection is slope. So finally we got this equation which we will be using throughout the session. Hope you understand this. This is fundamental mechanics of solid. What Iron Man is doing here. Now what is Young's modulus? If you see, like every human being in this world have different fingerprint, bioprint. Okay, for example, you are using Aadhaar in India, or criminal cases, they are trying to track the fingerprints. So Young's modulus are just like the fingerprint of the material. Got it? They will come to know. So by Young's modulus you will come to know which material it is, and it states how stiff a material is, or indirectly, like flexible rigidity, it's offer resistance against external stress and resist any strain. That's why the plot, if you plot the graph of stress versus strain, you get Young's modulus. So by Young's modulus we can easily find the good or bad behavior as it is, if CBI has to tell this dog is suppose a CBI, he will tell Young's modulus is just, it can easily find out how good or bad behavior is. Now this is the problem which we will solve by Galerkin method. So this is a beam and it is simply supported at two ends, and UDL is acting, or you can say force per unit length is acting throughout the cross section. UDL means uniformly distributed load. L is the total length and P is the force per unit length. Again this Hulk is jumping. Okay, now if you see, this is our fundamental deflection equation, EIdW4 by W is the deflection, or you can call it a trial function or deflection. Now if you see this figure where the Hulk is trying to jump, this part is red. Got it? This part is red because the deflection is maximum at this point. However, at the corner point it is blue zone where the beam is fixed. Blue zone means there won't be any deflection. That means at the end point the deflection is 0, and at the middle point, got it, the deflection is maximum, whether it's UDL or simply supported boom or a point load acting at the middle, deflection will be maximum at the middle. So this becomes our boundary condition. Hulk will break the bridge. Let's see. So many bats these days. Where is the Batman? Somebody save me from this bat. Anyway, now EIdW4 by dx4. This is our which equation we need to solve. Got it? Now, so what we will do now, we need to differentiate this term 4 times. Now this, if you see my previous video of a Rayleigh-Ridge method, I assumed a deflection equation. Now deflection equation Wx equal to C1 sin pi x plus C2 sin 3 pi by x by L. Got it? So this is our deflection equation. Got it? Which you have to assume. This is an assumption. This equation is Euler-Bernoulli's equation, but however this equation we assumed. So this is an assumption. You can call it a trial function also. So we need to put all this value in this particular equation. Got it? So again I'm repeating, this is our trial function C1 sin pi x by L plus C2 sin 3 pi x by L. So this is our trial function which we need to put in this equation. So we will write this particular equation by differentiating this. So these two are our trial function. These bats are disturbing a lot. Nobody wants me to teach in the class. Now simple differentiation, we will see this, why I'm telling this, we will see we need to differentiate this 4 times. So we have to differentiate f1x 4 times, f2x 4 times, because this is our trial function. We'll try to differentiate it. Now if you see, simple, f1x equal to sin pi x by L. So d sin theta by dx, if I have to differentiate, how I will differentiate? First d sin theta by d theta. To balance this d theta, I will balance another d theta. So it can be cancelled, these two terms. So there is no harm in putting these two terms. So I will ultimate result d sin theta by d theta is equal to cos theta. Got it? Now cos theta we got and d theta by dx. It's simple math. Similarly, d cos theta by dx is equal to d cos theta balance d theta into d theta by dx. D cos theta by d theta is equal to minus sin theta into d theta by dx. So similarly, if I solve first derivative of f1x equal to d sin pi x by dx, so d sin pi x by L into d pi x by L, same like this one. Got it? I just in place of theta I replace pi x by L. Hope you understand this step. So to balance d pi x by L into d, same like this equation. So if I solve these two equations, I will get cos pi x by L into pi by L, same like this. Similarly, if I second derivative, I will get a cos term. So if I differentiate this, I will get this term, same like this term. Only thing is pi by L is an extra term which we got from the first differentiation. Hope you understand this step. Again this Batman came. Now similarly, if you see, if I differentiate my first derivative, I got cos pi x by L into pi by L. Second derivative is minus sin pi x by L into 2 times pi by L into pi by L. So third time, if you see, for every differentiation, pi by L into pi by L is increasing. Got it? And plus minus is changing according to the differentiation. So you can solve this, try to solve it by yourself. I have given the fundamental in the previous video, how to get the derivative of sine and cos. So ultimately our intention was to get the 4-time differentiation. So when you will be differentiating 4 times, you will be getting sine pi x by l into pi 4 by l4. Got it? So this is our basic intention, to find the 4-time derivative of sine theta. Now if you see, so f1x 4 times, if I differentiate, I will get sine pi x by l into pi 4 by l4. Similarly, if I differentiate f2x equal to, I will get sine 3 pi x by l 4 times. This is our, so this is how we got the equation. Now who is this guy? Flash, I think. Okay, see, again all disturbing element in my class. This Avengers, actually they don't have works, that's why they are coming and disturbing class. Anyway, but we will concentrate in our studies. Anyway, wx is equal to c1 sine pi x by l plus c2 sine 3 pi x by l. So if you see, this is was our trial function. Got it? This was our trial function. So we need to, when we differentiated it 4 times, we got this c1 sine pi x by l into pi 4 by l4 plus c2 sine 3 pi x by l into, so I differentiated 4 times, so I got this term. Got it? So I will put all this value in this equation, which we have. This is our intention. So this is our residual function. So finally in Galerkin method, we got the residual function, which you, if you have any problem in understanding where we got, you can see, you can backward this video and check it. Just simply I wanted this equation. Got it? Nutshell I will tell. I wanted this equation, so I differentiated this equation 4 times and I have written. So this become our residual function. So what is our Galerkin method? The multiplication of residual function and trial function is equal to 0. Got it? So this was my trial function and this was my residual function. Now fully I have defined this equation. For example, this is my trial function and this is my residual function. So Galerkin method, what it tells, the product of residual and trial function equal to 0. So this was our trial function and this is the residual function, which you can check this video, this part. We got the residual function. Just I put all the values at one shot. Okay, Hulk is coming to disturb. Okay, he has smashed him. It just remind me of Avenger. I think Hulk is not liking his class. Professor stopped the equation, but this professor won't stop anyway. So again I will repeat, I took this trial function and residual function, I tried to multiply this both. So when I multiplied this trial function and residual function, I will got 0. So this is our Galerkin method. No, so now what we will do, product of residual and trial function is equal to 0. This is our Galerkin method. So I put all the values here. So now instead of taking this whole equation, I will only take one part, c1 sine pi x by l, only one part. Second part you can omit. Okay, or you want to do research or you want to expand it, and then you can take the second value, but I will restrict this session to only one value. Again, our students are so notorious. Got it? So what I have done, I just will take one term and I multiplied it. So if you see previous slide, I will go, just I took this one term and I will try to multiply this with this, I will try to multiply this with this, I will try to multiply this with this. So if I multiply all the terms, I will get all this value. If I multiply all the terms, I will get all the values. Now I will try to integrate. Again I am repeating, I just multiplied the previous one, this one. Just I multiply this with this and I need to integrate. So when if I integrate, if after multiplication I am getting this all. So what I will do, I will integrate all these terms individually to avoid the complexity. See, again this disturbing students, they bombed our professor, but the professor will teach. Oh god, now they started sleeping. Anyway, so this was the final question which we got from the previous one, equation 1, equation 2 and equation 3. So we'll try to solve each and all equation individually. So this is c1 square sine square pi x by l pi 4 by l4. So if you see here, sine square theta is equal to, if you see the maths, it's 1 plus cos 2 theta by 2. Got it? Sine square theta is equal to 1 plus cos 2 theta by 2. Got it? So if what I have done, ei c1 square pi 4 by l4 is a constant term, so it is out of this integration. It's a constant term, so I took it out. So if I took it out, I'm left with 1 plus 1 plus cos 2 pi by x. So we will try to integrate this. Please wake up, whoever is sleeping. Again, see, this baby is also sleeping, tired of equations. Anyway, so what I have done, first I will integrate the first part. So when I integrate ei c1 square sine square pi x by l pi 4 by l4, the constant term will be out. So sine square theta is equal to 1 plus cos 2 theta. 1 plus sine square theta is equal to 1 plus cos 2 theta by 2. So I put this value. So if I will try to integrate it, so it will be ei c1 square pi 4 by l4 into l. This will be l cube. 2 is, I will write at the previously, we can write it later. It will be divided by 2. So I have written it in the later slide. Now if I integrate 1 plus cos 2 theta dx, so integration of 1 dx is equal to x 0 to l limit. But if we integrate cos theta, it will be sine, for example, cos 2 pi x by l, integration will be sine 2 pi x by l divided by the term which had been multiplied, and limit is 0 to l, as length is from 0 to l. Now sine, if you see, it's just like a snake movement. It starts from 0 and it moves like this. So 0 to pi to 3 pi, but any multiplication with pi, got it, it is 0. So if I am multiplying, so you can see here I will get l by l. If I put the limit l by l, it will be 0. Sine 0 is 0. So this term will be cancelled. So only we are left with l. So finally we will be getting ei c1 square pi 4 by l cube divided by 2. Now we will try to solve the second equation. If you see here, ei c1 square, this is our second equation. So it's same like this equation. What I have done, I took all the constant term out. So e1 c1 pi 4 by l4, c2 81 pi 4 by l4, all constant term I took it out. So our equation is reduced to a simple trigonometric function. So if I integrate this just like this equation, for example, integrate 0 to l sine pi x by l sine 3 pi x by l dx, it's just like integration sine mx sine nx dx. So if I arrange according to this formula, I will get this equation. The slide where I will put in the link, so you can download there also to check the whole solution. Now integration of cos theta, so it is integration of cos 2x is equal to sine 2x by 2. Got it? So if I integrate it, you can see I will integrate by part here. So if I integrate this, I will getting this value. So again these all term will be cancelled, because if you see the graph, just like a snake, it is starting from 0, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi up to infinity, it is 0. So this whole term will be cancelled because it is a function of sine. So l cancel, 0 cancel, so everything will be cancelled. So finally we are getting ei c1 square pi 4 by l cube minus p into 2l by pi. Got it? So here I have missed 1 2, which you remember I have told you earlier that we missed, which we will balance in the last part, which I have directly put in the second part. Here I have not multiplied by 2. Here actually it should be divided by 2, which 2 I will show you must come from here. Just I will show you. This 2 I have missed it. Got it? So we will balance that part in the last part. So don't get confused. So we came to this part. Got it? E1 C1 square pi 4 by L cube. This will be divided by 2 here. Got it? So finally we will get this equation. So finally we got this 4p L4 pi 5 EI. So this is our intention to calculate. Similarly, if you calculate C2, you will get this. Hope you enjoy this session. Run before the next professor class starts. Okay, people are in hurry and finally everybody is happy. This boring lecture is finished. Hope you enjoy.